Okay, so now that we've copied all the groups, arrayed them through, we have our entire decking plan. So, next let's just start importing the load-bearing walls, and then I'll show you guys how to split those in order to achieve let's change this to coordination again. There we go. You can see I've already split a couple here and placed wall shoes inside, which automatically become a part of the assembly. So if we create views, our generic models become part of our assembly, so we don't have to place them in later. Anyway, so to the actual video, we're back in our structural model in progress. Let's reload the architectural. Okay, let's load back in. Remember, we only imported the we hid the walls, so we're just going to re-show those. VG, we're going to go walls, and just for easy access up this time I'm going to hide the floors. There we go. So we just have the hollow cores, the walls, so now we can start importing these and splitting them. So, continuing the old method, we're just going to go select copy monitor, select link, and go back into options and just see what we have here. How do we want to import the walls? Most of these walls I don't want. So I'm just going to go through the walls that I don't want to import, and I'll be great. So we've selected just three types. The 300mm load-bearing walls, floor type. I have some of them different for view filters in the architectural, but yeah, the load-bearing 300mm and the basement wall. That's all I want for now. I'm not even going to copy over the facade just yet, since we won't be splitting that in this model. We're going to be splitting that in a dedicated facade model for easy workings. So, press OK. Now we can copy multiple, and I'm going to go with the same strategy. I'm just going to copy over one unit, which would be, say, 4.5, 9. That is one unit. Yes. So, let's select multiple. As we can see, we're only selecting walls. Filter, just to double check. We have 79 walls. Seems like a lot. Double check. No, those are just load bearing. Perfect. And finish that. Great, so now that that's finally loaded in, we can finish the copy monitor and again unload the architectural. So, we have just the concrete load-bearing walls for now. That's fine. We're going to work with sandwich panels after that. So, we can go back into the precast and the configuration, and we'll just take a quick tour throughout the solid wall precast settings. Okay, so As you can see, before we were in the slab categories, we're going to close that. We're going to take a look at the solid wall. We have two options here. We have the multiple layered wall, that's going to be our sandwich panels, and we have the solid wall. Here we have the parts. The first is the lifters, which is the lifting elements. Just like the slab families, you can choose which ones you want. We only have one type loaded in terms of lifter here, and then the type. You can select the type, the strength of the concrete, and the distancing. This will be distance to the edge, and then if there is a door, this will be the distance to that, the minimum, and then we can specify the capacity, the lifting capacity, as well as if the wall is over 5 meters tall, the lifters will be put on the side. The bracing inserts, that's where the soldiers will connect. And generally, and this is which side you're going to place it on. So, for example, usually on the facade walls, the bearings are going to be on the inside because you're going to place the soldiers supporting that. So, if you select on view side, the side you look at when you press the split button, or is going to place it on the side you're looking at. I usually look at it from the outside, so I want it to be placed on the opposite side. And again, minimum distance. The last part is the connections. So the frontal wall connection, that would be one side of the wall. Oh no. There we go. Side wall connection. And this is basically just a generic void family, so it will place a family to cut the tapered connection, and you can select the size you want here. So for example, on the 300 millimeter thick walls, I'm going to want the larger taper. The front is when the end meets a wall perpendicular. I always want to select the larger void, and the T connections is when we have, we're going to select the largest one as well. And the profile is like before, it's going to create these division, and that's the horizontal. So if you have a wall that's too tall, you want the two walls to meet. In this case, the profile looks kind of like a jag, and the other one's another jag, and then they fit together like a puzzle piece. You can specify this by editing the family here. So let's just make sure I was correct and double check. So we open the file path in our folder, like that, and we find profiles, and we find the solid or horizontal profile. And we're just going to open this family. I believe it might not open because we are currently in this. So I'm just going to cancel out of that for now and open this again. Yes, we want to open the file and make it editable. So this is the profile. And so this is going to cut horizontally like this. So it's actually going to be, this is not rotated correctly. It's going to be rotated 90 degrees when you're cutting it. So one wall is going to look like this, and the other wall is going to look like this, and they're going to join. You can take these, you can edit them, I believe, by reveal constraints. One sec. Anyway, I can't find the hidden dimensions at the moment, but we'll just go into types and we'll create a 300 millimeter type just in case we run into any issues. So that's one type. This is going to be 300, and we're going to make a second type called 200. Turn this back to 200. So we can switch between the 3 and the 200. Great. And we'll just save it as a default. Apply that. Cancel. Let's see. Do we get any flex? Yes, we do. Great, so we can use this for the horizontal splits. So I'll change that back. Done. We're going to save this family. Okay, it's not going to let us, so we're just going to have to file, save this as a, save it again. Save as family. And it has to go into the same place. We're going to call this, I'm just going to rename this with my initials so I can tell the difference in the default. Okay, and then we don't have to load it into the project because this directory is going to find it for us. And you'll see what I mean when we close this and go back into configuration. It's going to have to reload the file because it realizes that it has a new family in there. Great. So, back to solid walls, parts. Right, this is where we're going to control what parts it's using. It remembers our settings. We're going to change this horizontal profile to the new one I made so we can control the type. The nooses are the wire boxes. The default is 3, and you can change the type if you have them. You can open the family, edit them, the models, and change them to the wire boxes or any kind of model you want to connect. For now we're just going to use this. And we can also add in a cast-in plate, which I think is made for the corners, but I'm not sure exactly what that is. The next setting, we go into segmentation. This is where we're going to control how the walls split. So for example, if you can do this in 2 ways. Either you can do this by maximum, so we know the maximum transport length possible is 9,000 millimeters, and the max wall height we can set to something. So I know we have some more than 3 meters, so if we don't want things to split horizontally, we have to set that to something else. Let's say our maximum according to our logistics company is 3,500, and we can lift, let's say our crane can lift a maximum of 12 tons. We don't actually want any horizontal gap. You can add a little bit if you want some tolerance, but I'm gonna add nose gaps and create those gaps myself. And yes, this is the distance to the opening, so it will tell us if whether or not some of our doors are too close. It's not going to split for example, where a door is going to be. You can say my doors can be 200 millimeters away from the end of an object, maybe not. And yeah. Then we can go into reinforcement. So this is where when you select the reinforcement tab, you can automatically reinforce your elements parametrically. So if you change the height or something, the rebar is going to automatically adjust to that. And here you can set how you want your corner bars to be around the openings. You can have U-bars, straight bars, L-bars. You can edit the overlap and the rebar type, so it automatically edits that stuff for you. And you can set, and then you can pick out of these when you reinforce. Do you want 2 layers in this, or 3 layers, and this and that? Of course, we're not going to want to show this in drafting views. We're only going to want to show this in shop drawing. So I'm only going to, in this case, I'm only going to reinforce 1. But if you want to have the whole model in LOD 400, you can reinforce everything at the same time. And then the shop drawings. So after you've created your elements, you can automatically create sheets and views for your shop drawings, which is going to make your production a lot easier. Here you can choose type, so the template. So it already comes with one. You can go into that folder here. You can find the title block, so it makes these sheets for you, and you can edit them accordingly to how you want them to be printed. So that's just selecting the type of title block you want. Dimension types, because in some cases you can dimension things automatically. And yeah, so if you have a title block edited, you can choose the type you want, so when you create them automatically you get the one you want. So, but we did everything we wanted. Now I'm going to start splitting them. And you can do this with all the walls, like your room bounding walls as well. I'm just going to do it with the load bearing for now. Okay. So first things first, we're going to have to change these all to the same type again. And just for demonstration purposes, I'm going to use PyRevit, because I have this pick tool and I don't want to have to filter out. I just want to pick the ones I need right off the bat. So I'm going to find walls, and now I can click drag, and I'm only going to select walls. And since I know they all have to be the same type, but I got these strange secondary types, I just want one. I'm going to change them all to the same type, to this 300mm concrete wall. Great, now we can select all. We know every one of these is load bearing, so we have to set that SA to control that to a structural. In Revit 2023 it has a new setting here, so you can turn your non-load bearing walls into structural elements. You just have to define it here. So when you turn to structural, you get these options: structural usage. We're going to turn these load bearing walls are bearing, they're not just shear. They're not just for stability, they're actually going to carry load down to the foundations. Great. So now that these are structural, I'm going to take 2 approaches. I'm going to select all of these, and since I've defined my maximum splits, I'm going to just go to the Precast tool and split it. And I'll be back when that's done. Okay, some of them are smaller than the maximum setting, so let's go back to the Precast tool, configuration. I'm guessing this is minimum openings, so it's probably not wanting to split these. So I'm going to cheat. I'm going to say the minimum can be just 100, even though that's unrealistic, I know, and I'm just going to take the minimums. And adjust them so I can get a final result. Select all again, and Precast. One second. Okay, and so we're going to split them, see if that fixed the error. This is going to take a while, so I'm just going to pause the video. Okay, so now that that is done, you can see that the elements have been split. So, using the segmentation tools, you can see that it's done. However, it's It can be a little unpredictable in certain places. So for example, these. Why there is an opening here, I do not know. You can find the assembly, you can edit the assembly, and see if we can select, you know why? Again, it's with the VG. So like I said, these voids here, these cuts, these are made to be meeting another wall, but these are generic models that are placed. So if we show generic models again, we're going to see all our generic models, like the nooses. There was a certain ones we didn't really want. So what we can do is we can edit the assembly, and you can see this is the generic void family. So it's here. Why is this splitting a wall here? I don't really know. Like I said, this tool using the segmentation can be a little bit unpredictable at times, but it still saves you a lot of time. Like we have this wall, and if you have to pick an interesting precast wall, I would say this is pretty interesting. So if you want to use this one for your individual, right, you can create the views for you, the part schedule, the generic model schedule, the structural connection schedule, anything you want to put on your sheets. It'll create the sheet, which one you want. You can choose anything from the family, the ones that it makes automatically, or you can create this one, the one we're using for the rest. Create the views. Go down to your assemblies. We can see all our hollow cores, all our solid walls. Find the view and open them. By default, these views, for whatever reason, have parts hidden from default. So we just have to go into VG, create parts. We don't want to see the wall. Let's turn off, let's go to a shaded view, and we have a pretty interesting looking precast element with the nooses placed and everything. Back to the 3D view. Let's say we've chosen this one, right? We can go to the precast tool, reinforce this element. We can do 2 layers because it is structural, and we can choose corner bars. Let's just edit it. See if we're using the correct diameter. So this is one side, one leaf, and you can see the position is on the inside of the wall, and this one is on the outside, and this is defined by is the wall drawn the facing interior or exterior. And we can choose the outside. We can see has a larger web, a stronger web, while the interior has a slightly smaller one. So that looks good to me, and we're going to press OK, and this is going to automatically reinforce the element for us. If you have a joke, share it with the rest of the class. I think so. Anyway, so that loaded up. If we show VG and we go to structural rebar, which we don't really want in most of these views, because remember, when we're doing drafting, we don't want to see the rebar. We just want to see it in the... So we have area reinforcements and we have structural rebar. There we go. Now our wall is reinforced. So we go back to the 3D view. Those rebar from reinforcements automatically become a part of our assembly. So we don't have to go in and out and add anything. Everything's there ready to get dimensioned. To keep going with this, to make this even cooler, I'm going to load in a family. I'll be back in a second. Okay, so I just loaded it in. I want to go to both because it's a wall-based family, so I can't place it on parts. I need the wall visible. Great. So we know we have this wall. Let's do both so I can still see you can show both wall and original, so we can place wall-based families, but we can also see the parts so we know where we're placing it. So let's say we want to have 2 wall shoes per element. We're going to close that for now. Families. It's a generic model. These Pico wall shoes. There we go. So we want to place it into this family. Right there. There we go. Now we have a wall. We place the wall family into the wall, but you can see now this precast element, the assembly is updating. So when I place this family here, this wall shoe, we can edit the type, extend the rebars, add the screw, the meeting part. Right, you can see it even cuts a hole out of it. It's automatically added to the assembly. Like that. We can't see it right now because in visibility, my assumptions are generic models. No, they're turned on. We can see the cut. We can't see the thing. My next guess is, the reason that is because perhaps this isn't actually part of the assembly. So what we have to do is just edit the assembly, click on the wall shoe, and now it's part of the assembly. In order to make this automatically part of the assembly when you split, is you would first place the wall shoes, and then you would split, and then the generic models that are hosted to the walls or the floors would automatically become part of the assembly. So, if we go back to this orthopedic view of our chosen wall, we now have our wall shoe built into it. So, we go to assemblies, find our view. Let's take a look at an elevation from the front, or the left, which is the one with the wall shoe. There we go. So because we are in this view that doesn't automatically show parts, we don't see the wall, so you can use this view for the rebar and bracings and lifting elements. Voila, just like that. And then you can just open the sheet that it made for you automatically, this one, and you can just start dropping the views. So we can have our 3D up here. Then let's take this one to show the rebar. And let's take a section. Oh, same thing basically. Let's take a short section. There we go. Then it's done. You can just manipulate the views to show what you want, add some dimensions. And is this view locked? Let's lock this view so we can dimension our 3D. Whoa. 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 Not what I wanted. You get the point. You can edit the families, the news families and everything, and yeah, here you go. In the next episode we're going to do sandwich panels for the facades, and we're going to do one for the load-bearing facade elements, sandwich panels, and we're going to do one for the self-supporting ones for the facade individual. I hope that helped, and see you next time. Ciao. So, I forgot to mention one thing really important. Just like the hollow cores that we did earlier, what we can do is we can turn back on the originals. We can select the walls, right? And we can group them. And this will group all the walls, the parts, and the assemblies, including the reinforcement. So let's say we do this one unit really well. If we want the whole model to be an LED 400, we can, even all the reinforcement and everything, we'll group this as solid. Load bearing walls unit 1, okay? And we'll save that as a group. Now everything is ready to get copied, and just like before, if I copied it over, finished it, it'll recreate all the splits and all the wall shoes, all the reinforcement, all the lifters, everything will travel with them. So what was that? That video's half an hour long, and half an hour minus loading times. There's been some cuts and edits where these could take upwards of 20-30 minutes to create the splits. You know, another 2 hours and all your load bearing walls are done. So you have hollow cores walls, and now we just have to have the facade elements and production drawings, structural models in LOD 400. It's really that easy with the precast tools. So yeah, that's done.